I forgot it. And like I said, there are several types of classification of transistors, but we are just going to focus today with BJTs, or these are now what we call your bipolar junction transistors. So why that it was called bipolar? Because of this one. So last Monday, we did talk about, of course, what are the different types of materials in a semiconductor. So we have the N-type material and then we have the P-type material. A diode was or is considered as the most simplest semiconductor is because that it is only a combination of one N-type material and one P-type material. Yun lang yung diode. So for a diode, we have here example of P-type material, and then we have an N-type material. You combine that one, you have now what we call your diode. So this is an N, this is now a P. So again, when we talk about bipolar junction, it means that you have now two junctions in a semiconductor. Again, two junctions na ginaistoryahan natin. Another type of a transistor, we call that one as your MOSFET. But like I said, the most common na makita ninyo is this one, the bipolar junction transistor. Now, BJT consists of three regions. It's either 2p-n junction or 2np junction. So when we talk about 2p-n junction, you have here example, tatlo man na siya gihapon, basta maghambal ako nga 2p-n junction is because we are only talking about the junction, not the combination of materials. So example, this is now your transistor. When I say 2p-n junction, the typical type na sa material is we have it now here your PNP or NPN. Duwa na siya kaklase, the PNP and then the NPN junction. In this case, if you notice, when we talk about two junction, is we have here the first connection, and then the second connection. So this one can be considered as one PN junction, and this one again can be considered as the second PN junction. That's why it is said that it has three regions with two PN junction. What are the regions? 1, 2, 3. Those are the three regions. So that is now what we call your BJT transistors. Now, all BJT transistors are made up of three regions. All ni siya, regardless of whatever NPN man na siya or PNP materials ang combination niya, but they have the same regions. One is what we call your emitter, the other one is called your base, and the other one is called your collector. Again, emitter, base, and then collector. Why is this very important? It is important is because we need to understand these three regions in order for us to be able to solve for your current and voltages in the different region. Now again, we have the collector, the base, and then the emitter. So here, two types of BJTs. We have the PNP and the NPN, separating, of course, by two junctions. Now, let's talk about the different regions. So I said you have the emitter, the base, and then the collector. Which or where are they connected? Or how are they connected with one another? I'm going to shift to the whiteboard because it's easier for me to discuss this one in a whiteboard. So please do follow with, if you have the PowerPoint, the PDF, please do follow this one. If you do have any problems with the the terms, and of course, and later on the different symbols. Now again, so we are talking about your transistors. So now this is now, ano ba? Early in the morning, ayaw mag-straight ng line ko. Straight lang. Again, this is now your typical transistor. And regardless of this is going to be NPN or PNP, they will still have the same regions. So we have now your emitter, your collector, and then your base. Okay, so this is now your collector, this is now your emitter, and this is now your base. Where are we using the following region? So let's just stick with the NPN. Dali lang kita ha. I'm not going to discuss anymore the PNP. Basically, they just have the same formulas. The only one of the difference would be the arrow, where your currents are going. I am not going to confuse you anymore, so we will just stick with the NPN na BJT or your bipolar junction transistor. Again, we are just going to discuss the NPN. I am not going to discuss anymore the PNP. The theory are the same. The theory are basically consistent all throughout. One of the not the problem, but one of the differences with the NPN and the PNP is that the current is or has a different orientation. Yun lang. Yun yung difference na. Now, this is again your typical transistor. How does a transistor look like in real life? So, kung mang-ukay ka muna, transistor radio, whatever you have there, an electronic device, especially the bigger ones. So, this is what you see in a smaller setting. But if you have example a transistor radio, a very old radio, you could see this one. So your transistor would look like this. So it has three legs. The three legs there, of course, depicts your collector, your base, and your emitter. Depending, again, now please remember, depending on the transistor, the placement of the leg is usually collector, base, emitter. Usually, ang base mo ara sa may tunga. This is the side view of the transistor. The top view, usually this is now a semicircle and then flat. So, yan yung semicircle dito. Ayun. So, that is now the actual appearance of your transistors. So, your very first activity is basically to draw the actual appearance and then the schematics, of course, of the different components that we are using so that you will be at least aware of how they look like in real life. Now, this is how a transistor would look like. The schematic diagram is simple. This is now the schematic diagram of your transistor. So we have here, and then we have three legs. This is usually the base. This is now your collector. This is now your emitter. In the NPN transistor, the arrow is usually going down. In the PNP transistor, the arrow is going up. It means that the current is going in. Like I said, we're just going to content ourselves with the NPN, so not to confuse everybody. The arrow in the NPN transistor is usually going down, which means that your current is going down. Now, where are we connecting the base, the collector, and the emitter? Now, your base, this is usually your switch, or this is usually your trigger. Your collector, this is usually connected to a power supply. Typical, the power supply is a, let's say, an outside power supply or a different power supply from your base. And then your E here, this is your emitter. This is usually connected to the load. Again, your base is your trigger. Your C is your power supply. Like I said, this is usually an outside power supply or an extra power supply. And your emitter is connected to your load. This is the most common, again, this is the most common, mali pala, not common, but this is how your transistors are connected. Where can we use this one? Now, balik kita sa beloved ko nga project in college. Now, I used transistors before as a triggering mechanism. So why do I need to have a transistor if it is just a trigger mechanism? So pwede ko man siya idiretso, di ba? Like example, if I have a light, just like what we are doing right now, or a typical switch, not a trigger, but let's say I just have a typical switch, and then it will be now connected to a light. Why do I need a transistor to do the work of my switches? Okay, now, here when I talk about trigger, this is usually, the switch is usually an electronic switch. Okay? Kasi most often than not, we would see this one if we are going to, example, in my case, I use this one to connect to a computer. Now, on a typical scenario, your transistor here, like I said, work as a switch. Why do we need this kind of switch if we just have a on and off button? You have to remember that this switch right now is being triggered by electricity. This is not a manual switch wherein you're going to turn on and off a certain part of your circuit, but like I said, this one is usually triggered by electricity. So, again, balik kita sa definition of electronics. Electronics means electricity controlled by electricity. In this case, in your transistor, your switch cells are being controlled by electricity rather than the manual turning on and off of a certain switch. So, why kailangan pa nito kung may switch malang di umutang ta, may switch ako di nga Another instances kasi in an electrical design, especially if we're dealing with, of course, electricity, there are tendency that, of course, there are leakage voltage or leaking of voltages. Pag may leaking kasi of the voltages, one of those problems is that even though na may switch ka din, especially kung kaisabla when we are talking about electronics, there are tendency that this might not be totally go off at 0 volts. It might be on 1 volt, 2 volts. There are trickling of currents and might turn on your load. So in that case, what will happen is that medyo kung kaisang dim ang light, kung kaisang nag-flickering of lights, now this is being solved by your transistors. It will not totally turn on or it will not become a conductor until such time that the base current will be able to supply the voltage that it needs. Again, it will not turn on until such time that the base gives it the voltage that it needs in order for it to conduct. It is usually around, ang trigger sa main, usually ara sa 0.5, ara sa 5 volts. Ang typical na trigger ha, ara sa 5 volts, 4 volts, depending on your design and depending on the model of a BJT transistor that you are using. Now, let's talk about biasing. So, in your transistors, in your diodes, we did talk about biasing. We have the forward bias and then we have the reverse bias. When we talk about forward bias, of course, that is the time that your semiconductors become a conductor. When we talk about reverse bias, it means it does not allow your current to pass through. So in this case, this one, this is the forward or the BE, or that is now the base emitter forward bias. And then in here, we have now the VC, reverse, wrong spelling ako, reverse bias. Okay, so it means that your current could not go up, it could only go down. Again ha, kay reverse bias siya, it means that your current can only go down, it could not go up to the collector. So how are we going to connect your transistor in a simple circuit? Now, this is the simplest circuit that we could have for a transistor. And then, in this one, we're going to start solving for the different parameters of each of the different regions. Okay, before that, I will be inviting everyone. If you have the time on Saturday, we are having a review for this one, especially that we might only have time to have one problem. So please, if you can, please join us on Saturday for the review so that we could have more problems in your transistors. Huh? So in this case, like I said, this is the simplest. Tama ba? Wait lang ha. Parang sobrang laki na ano ko. Drawing ko. Now, again, so we have here. Nahon ko na lang siya. So this is now your base. This is now your emitter. This is now your collector. Again, this is the simplest. Huh? This is the simplest circuit that we could have. And it have. Okay, now, again, this is now the simplest circuit that we can have. So in this case, again, this is your base, this is your emitter, this is now your collector. I will be transferring for different different colors every now and then ha, para hindi kita magsala. In this case, this is now your VDD, or this is now the voltage in the base. So we call that one as the VDD. Again, change color para kitanon. Yeah. This is now your VB. So VB, this is now your RB or the resistor at the base. This is now your RC or the resistor at the collector. This is now your VCC or this is now your voltage at the collector. So VBB, this is again the voltage at your base, RB, RC, and VCC. If you notice, in this side, tanan mo side niya connected kay B, that is labeled or they are labeled as B. So voltage at the base, your resistor at the base. All components connected naman kay C, that is now your resistor at C and your voltage at C. Wala pa ko nagdugang sang RE, ha? Dugangan ko na later on, pero dili lang ko taanay ma-focus. So, like I said, this is now your typical connection on your resistor. Now, how are we going to solve for the different components? Ano mga parameters na pwede natin ma-solve? Okay, so here, you can solve for, of course, my ID, kita? That is the current. So we have here your ID. We have here your IC. And we have here your ID. At the same time, we have here your VRB. We have here your VRC. And here, we have here your VBC. And then we have here your VBE. Sino si VBC? That is now the voltage between the base and the collector. VBE, that is now the voltage between the base and the emitter. I do hope that one is clear. At the same time, may ara kita VB lang git, which is the voltage at the base. So we have your VC here as the voltage in the collector, and then we have the VE as the voltage in the emitter. Medyo damo terms lang gid diri, pero they are simple to solve. So we have here your VE. Kasabad sa ako niya, ano nga handwriting nga, medyo magamay. So we have here your V. So we have here your VB, your VC, and your VT. Okay, so how are we going to solve for the different components? Now, the easiest way to do this one is basically to follow the loops. So when I talk about follow the loops, we are now talking about closed loop in your circuit. Di ina ko kakita sa closed loop in my circuit. Now, this is loop number 1. Na consider siya closed loop, syempre, close niya siya off. And then this is now loop number 2. Okay, so again, this is now loop 1. And then this is now loop number 2. Do I need to remember any other formula here? There is only one formula that you need to remember here, which is hindi natin pwede ma-derive. Again, the rest of the components here, we could derive that one. There is only one thing, sorry, that we could not derive. And that is now what we call your beta. Now, the beta here, the beta is equal to I sub C divided by I sub D. This is the only thing that we could not derive. Where will I get this value? This is usually given depending on the transistor that you have. So again, this is a characteristic of the transistor. Depending on what model, what what model series or transistor is, that is where we are getting the beta. Okay? Again, that is now the only thing that I could not derive in your circuit. Your beta here, this is now the ratio between the I sub C and I sub D. Again, your beta is usually says the relationship between your I sub C and I sub D. Okay, now let's try to derive all of the different parameters here. Again, all of this can be derived. And one of the reasons why we are going to derive it right now, so that when you have the problem, you do not need to just remember the formula. All you can do is take a look at the problem and you can derive, of course, the solution. Now, let's start with loop number 1. Okay, loop number 1. Now, in loop number 1, if you can remember your if you can remember, of course, your KVL, it says that, ano ganun sa KVL? It says that the summation or the total of all the voltages in a closed loop is equal to 0. So if this is my source voltage, it means that my VRB plus my VB is equal to my source voltage. Again, at loop number 1, using KVL, I could say that VDB minus VRB minus the VBE is equal to 0. That is loop number 1. Where did I get the idea? That is now my KVL, or that is now your Kirchhoff's voltage law. Again, what is Kirchhoff's voltage law? It says that the summation of the voltages in a closed loop is equal to 0. So it means that the voltage being used up by your resistor here plus the voltage used up by your VDE here, or the voltage between your base and your emitter, is equal to your source voltage. Ano pang madumduman mo? Dire, kay since this is a forward bias, VBE here is always constant at 0.7 volts. Constant na siya. Wala na kita na baisan, that is not a constant value. So we could just say that VBE minus VRB, is equal to VRB minus 0.7. Okay, that's one. Now this is derived by just using your loop. Now let's go to Ohm's law. Ano naman si Ohm's law? So VRB now here. Sorry. VRB is equal to I sub B R sub B. Yun lang. Now, if you are being asked to solve for I sub B, so I could say now V B B is equal to VRB minus 0.7. So VBB is equal to I sub B R sub B minus 0.7. So balik ka doon ta lang siya, may mo siya I sub B R sub B is equal to VBB minus 0.7, or I sub B now is equal to VBB minus 0.7 divided by R sub B. So this is now my first current. O, yun lang siya. Now I have my I sub B. Now, let's go to loop number 2. Dali naman masugot. Loop 2. Ano ba? So we have now again loop Now in loop 2, this is now my loop 2. So this is now my source voltage. Same thing. Loop 2, I am still going to use the KVL. So VCC minus VRC minus, of course, we have here now, diri, ang kwao natin is the VCE. That is now the voltage between your collector and then your emitter. So, panaog na siya ha. Hindi kita manaog, ginain siya, oh. It will go here to here. Ang dali mo naman, hindi pwede kasaka ang mga current from this one. So, manaog lang siya. So, minus V CE is equal to 0. Okay lang naman siya ha. So, clear niyo siya. Guys, are we clear with this one? Guys, are we clear?
Excuse me, ma'am.
Yes.
Dinhalin ang constant nga 0.7 volts sa loop number 1.
This one is hambako ganit, di ba? That is now yung property na sa inyo nga na diode. So, di ba hambay ko sa inyo Monday nga ang diode, ang iyang ginakaon na voltage, ang iyang gina-use na voltage is basically equal to 0.7 volts. So, it follows there. It is 0.7 volts.
Okay, ma'am.
Okay? So, now we have this one. Here, we could now say that V RC is equal to I sub C R sub C. Clear ni siya? Guys, is this clear?
Yes, ma'am.
Okay. Tama. Okay. So, eto na tayo. Asa na ba ako? Okay, in this case, so now I have here my I sub C. I have here my I sub T somewhere there. Now, asa na ba ako? So, dito na tayo. Okay. Sige. I'm trying to make this simple na din. Ha? Now. Sige. Okay. So in this case, we have now here your VCE. Now the VCE is usually, this is now equal to VC minus VE. Oh, sorry. VC tama, minus VE. Your VE is usually equal to VP minus VE also. Okay? So can we get your values from this one? Okay ha, try ito kung mag-get natin ang values natin from this one ha. Now your VE here, since this one does not have any load, so it means your VE here is almost equal to 0. Am I clear? Guys, am I clear? Sige na lang. Let's make this one simpler na lang. Hindi na lang ako mag-add din. Now, here, so in this case, we could now say your VCE now is equal to VCC minus your VRC. Or in this case, we could now say your VCE is equal to VCC minus your I sub C, R sub C. So yun lang siya. Dili lang kita masap. Kaya masap po siya isolve kung may value na kita. Now, in this case, that is now your different value. So how are we going to solve for I sub E and I sub C? That is simple. You have to remember that we could now use your KCL here. So KCL at this node, let's say that is node A, at node A is just equal to current leaving is equal to current entering. So, dili ako ha. So, kung basihan natin ang loop, sino nagasulod kag sino nagagwa. So, at that node, this is node A. Ang nagkasulod kay node A mo is your IB. And then, we have here your I sub C. And then, ang nagagwa kay node A mo, that is I sub E. Are, i-follow pa lang yung directions ng loop mo. So, going inside node A, this loop, anong gasunod? Si I sub C, diri naman si I sub B. All you have to do is follow the direction of your current. Who is going out I sub node A, that is your I sub E. So, we have this one. In this case, we can now say I sub B plus I sub C is equal to I sub E. Since we already have your current, can we now solve for this one? Yes, we can. So kung ara naman lang ang current mo, all you have to do is basically substitute the value of the current and then you could solve for the different parameters. Okay, let's have a very simple example so that it would be easier for you to follow me. Now, since we are pressed on time, ako na lang sa calculator ha, pero please follow me ha. Para we could have your value. Okay, here. Let's say, let's have this one. Let me look for a very simple example. Huh? I don't like this one. Ito naman ito binukang. Wait lang ha. I'm looking for a simple. Ay, sorry. Wait lang. No, 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 no. Not that one, not that one. Sige na lang. We'll use this example na lang. Ayun. Found it. Okay, let's have this example. Now, mouse, mouse. So we have this one. Okay, so here we have the following values. So R sub C here, R sub B. This is now your VBB. This is now your VCC. Now this one, this is 100 ohms. This one, this is now 10,000 ohms. This one is 5 volts. This one is 10 volts. Ayun. Then we have now your NPN resistor here, a transistor here. Now, based on our loops, so this will now be loop number 1. This will now be loop number 2. Okay, so we will start first at loop number 1. So beta here, this is now equal to 150. Now, you are being asked to solve for the following parameters. So, solve for I sub B, I sub C, I sub E. Then we have your VBE, your VCE, VRC, and VRB. So these are the different parameters that we are going to solve given this problem. So let's start at loop 1. So at loop 1, hambal natin, this is now my loop. So we follow the loop. So we could now say VBB minus VRC minus VBE is equal to 0. Again, VBE here is constant at 0.7 volts. So we were able to have the value for this one. Now, since we have this value already, we could substitute this value to your equation. So we could say now VB minus VRC minus 0.7 is equal to 0. Or i-interchange ta, VRC now is equal to VBB. So your VBB here is 5 volts minus 0.7 volts. So VRC now is equal to 4.3 volts. So yun. May VRC na kita. Now, VRC, like we said, VRC is just equal to I sub C times R sub C. VRC, VRB pala. Bakit ba VRC na po nasulat ko? This is B ha, we are in B. So VRB is equal to I sub B R sub B. So I sub B here, we already have the value of the VRB. We get it from here. So this is now 4.3 volts divided by 10,000 ohms. I sub B now is equal to 4.3 divided by 1,000. 10,000, this will give us 430 microamperes. So this is for 30 times 10 raised to negative 6 amperes. Either way, they're the same. So I have now my I sub B. Okay na siya. So I sub B, VRB, wala ka pa masawang si VRC. Nawili ako kasulat. Okay? So we have this two. Now, diin ako sunod na kanto. I could now go to my loop number 2. So at loop, okay, before pala ako mag-go kay loop 2. Here, nasabad sa kanta. Okay, now, here at ang beta natin, if you can remember, this is now the, ano ganing beta? This is now the relationship between my I sub C and my I sub D. Beta is given. So I sub C here is basically equal to beta I sub D. So in this case, I sub C now is equal to 150 multiplied by 430 microamperes. So I sub C now is equal to 0.0645 amperes. So I have now my I sub C. I sub C, okay. Again, KCL will tell me that current entering is equal to current leaving the node. Din ang node ko, ari di node ko, ari di ang I sub B ko pakadto. Ang I sub C ko naman, ari di. I sub E ko is here. So I could now say that I sub E is equal to I sub B plus I sub C. So this is now equal to 430 instead raised to negative 6 amperes plus 0.0645 amperes. I sub E now is equal to 0.06493 amperes. So I already have my I sub E. In this case, I could now cross out my I sub E. May I sub E na ko, may I sub C na ko. In this case, I could now solve for the VRC. VRC is just equal to I sub C, R sub C. So this is now equal to 0.0645 amperes multiplied by 100 ohms. So 0.0645 times 100, this will now give me 6.45 volts. So again, this is my VRC. So I have this one already. Ayun. I am left with the VCE. How to solve for the VCE? This is now at loop number 2. Anong loop number 2 ko? VCC minus VRC minus VCE is equal to 0. So basically, VCE here is equal to VCC minus VRC. This is equal to 10 volts minus 6.45 volts. VCE now is equal to 3.55 volts. Yun lang. And that ends your transistors. Questions so far? Guys, questions so far? Questions? Guys, questions? Anyone? Wala? So I'm guessing that everybody understands this one? Okay. So I guess, guys, you don't have any question for this one. Yes, Tim.
Ma'am, ano galit mamang topic para sa final exam?
Final exam, like I said, it will cover from start to finish, but tanan is multiple choices.
Okay. Sige, ma'am.
Pati problems will be multiple choices, ha?
Alright, ma'am.
Okay.
Got it.
This is usually what I do sa finals. If you can get more than 70 points, automatically you pass my class. Basta damo ka pala kulang sa akon, so on and so forth, basta naka 70 ka, it means that you are assured of the tres. Your score or your grade might just go up, but it will not go down. 3.0. So that is usually the challenge that I give my students. Are we clear on that? So please do study. Yun, para hindi na kamo problema sa December ninyo. Are we all clear?
Excuse, ma'am.
Yes, bro. Ano ka pang
Din ma-access ang recording, ma'am.
Hindi siya. I will be uploading this one by later today or by tomorrow.
Thank you, ma'am.
So all of the recordings are there. From start to finish, everything is there.